For our next example, I'm going to go ahead and pull one from WebAssign here because it's a little bit more complicated and I want you guys to kind of see the full process and also demonstrate some more ways in which we're going to use right triangle trigonometry to solve different types of problems. So with this particular one, we're taking a look at a passenger plane where we are 10 kilometers above the ground. We see two cities that are directly east of our plane. The angles of depression to the two different towns are 55 degrees and 26 degrees, as you see here in the figure. So this is kind of an interesting problem, partly because we're dealing with angles of depression rather than elevation, and also that to find the actual distance between these, we're going to define the distance from the plane to each of these different towns. So that's going to create an extra little bit of work for us. First, let's address the angle of depression part of this. Let's say that we want to go ahead and find these different distances. There's a couple ways in which we can handle it. We can go ahead and use these angles of depression as the angles here down in the bottom of our graph as those angles as well. So for example, this 55-degree angle of depression, since this plane is assumed to be flying parallel to the ground, will also have 55 degrees here as the angle. And similar here, this angle of depression 26, assuming that our plane is parallel to the ground, we also have an angle of 26 degrees here. That's one way to tackle it. In addition to that, we could have also gone ahead and used complementary angles to deal with what else we have. If this angle is 55 degrees, then this angle here has to be, in this case, since they sum to 90 degrees, 35 degrees. And if this is 26, we know that this needs to be 64 degrees to sum to 90. Those are different ways to approach. For right now, I'm just going to stick with the angles given, and I'm going to redraw this as two separate triangles so you can see the full idea that I want to work with. In this case, if I'm dealing with these two different triangles, the idea here is that we start with each one of them dealing with a height of 10 kilometers. We're going to find the distance from the plane to each town separately. So our first one, where our angle is 55 degrees, and our second one, where the angle is 26 degrees. We need each of these so that we can take the difference to find out how far apart they are from each other. In this case, based upon the information that I've got, I want to find the adjacent side and I know the opposite side. So in each case, if I want to find this adjacent, but I know the opposite, I'm going to go ahead and use my tangent function. So tangent of 55 degrees is going to equal opposite over adjacent, so 10 kilometers over A. And same thing here. I'm going to call this A sub 1 for the first town and A sub 2 for the second town, so we can differentiate. The tangent of 26 degrees is equal to 10 over A sub 2. We're going to find expressions for A sub 1 and A sub 2 and find their difference to actually find the distance between the two towns and not their distance to the plane. In these cases, we're going to make use of the fact that if we multiply both sides by our adjacent side's length and then divide by the angle, or excuse me, the tangent of the angle, these become A sub 1 equals 10 over tangent of 55 degrees, and A sub 2 equals 10 divided by the tangent of 26 degrees. In this case, the town that had an angle of depression of 26 degrees is the further away of the two, so our final answer should be A sub 2 minus A sub 1, or 10 over the tangent of 26 degrees minus 10 over the tangent of 55 degrees. On an exam, you would leave your answer here, but for WebAssign, we're going to find approximations for each of these two values and an approximation of their difference, paying respect to the number of decimal places that they ask us for us to write our answer to.